Hello. Welcome everyone to another day of daily LeetCode live streams. Today is Tuesday, September 27th, which means we're going to do some medium questions. From what I can see, it seems like a lot of you have reacted very positively to the medium style questions, even more so than any of the easy ones I generally do. The two that I've already uploaded have gotten a lot more views than, like I said, some of the easy ones I've done before, so that's a very good sign. It makes me feel good. I know a lot of people really do value the medium questions. I'm still going to be doing the easy questions, but I might even up it more in the sense that I might do Monday, Wednesday, Friday, easy, Tuesday, Thursday, Saturday, medium. Might do something like this. If you guys stick around, then you'll see it for yourself. If you like LeetCode, if you like problem solving, if you just like watching someone code and listen to them, hear them, talk about their thoughts and what they're going through, make sure to hit subscribe on YouTube or follow me on Twitch. It helps me a lot with the algorithm, and we've had tremendous growth in the last couple of days. So I'm very happy about that. I'm looking forward to hitting my next milestone at 500 subscribers. That way I can unlock the community feature, which will allow for me to communicate a lot more with my community and just become more interactive and do things like polls and ask you all questions and so on and so forth. So we're currently sitting at 291 questions. Out of those, 284 are easy questions and 7 are medium. Today, like I said, we're going to continue with our medium journey, and we're going to see how far we can go. So let's go ahead here and let's start off with this one. So this one here says count nodes equal to the average of subtree. So it says, given the root of a binary tree, return the number of nodes where the value of the node is equal to the average of the values in its subtree. So the average of n elements is the sum of the n elements divided by n and rounded down to the nearest integer. A subtree of root is a tree consisting of root and all of its descendants. So let's see. Here it says for the node with the value of 4, the average of its subtree is 4 plus 8 plus 5 plus 0 plus 1 plus 6. So I think we always need to, I think one way to solve this, let's think about how we can do this, because I could take the sum. I can go and take a sum through like each one of these, and I guess at any point, right, I can go left and right, and that will be the parent. Here I come up here I go right, left and right. This will be the parent. So I can sort of like take, I might be able to just take the sum, and then I can also count the amount of nodes, like the amount of nodes I've seen at every point, where this one also composes of the node. So here it's 4 plus 8 plus 5 divided by 6, because there's 6 in here. 1, 2, 3, 4, 5, and this one itself. So, hey, what's up, Marvin? Thank you so much for joining. Good to see you around. Hope you've had a great Tuesday. I'm in South Florida, so the weather has been on and off here. I'm not expected to get the brunt of the hurricane coming through, but hopefully I'll remain with power and I can continue doing my streams and just my normal daily work. So I think what I want to do, you know what I'm going to do? I'm actually, before I even start coding, because one thing that I've talked about before is how drawing really does help in the overall, design of your algorithm. So I'm going to, especially for medium questions, I really want to focus on also planning it out before I start even writing anything. So I'm going to create the same binary tree that we have. And I think, yeah, it's a binary tree. It's not our binary search tree. So here we have a 4, here we have an 8. This is a 0, this is a 1, this is a 5, and this is a 6. I think what I want to do is I want to have two variables that are, I wouldn't say global. The medium has started grind. Oh, so I don't know, maybe you weren't here when I announced sort of what I was going to do, but I'll just give a quick recap. So mostly for, I know there was a lot of people that wanted medium style questions, and I know that there's a lot of value for people to see me go through these questions, but I also know there's also value in easy. So what I decided to do was, and it actually makes it more fun for me too, is on Monday, Wednesday, and Friday, I'm going to do easy questions. On Tuesday, Thursday, and Saturday, I'm going to do medium questions. I don't have any plans to do hard questions in the future, not just yet. Maybe after doing like 100 mediums or something, maybe I'll incorporate one extra day in there for hard. But I think now this gives a nice balance, so we still have content for people that are wanting to watch easy style questions, and we also have the content for people that are wanting to watch medium style questions. because from what I can see, the medium style questions are definitely doing better than the easy questions. So I'm going to keep pursuing that, but still trying to keep a nice balance. Okay, so I want to have like two variables that are global, not global to say, they're still going to be scoped to the average of subtree function. However, I'm going to create an inner function in here that's going to do the actual traversal. What I want to do is I want to have one, let me see. We just want to return however many nodes there are. So I think, right, like if I start going down here, let's say I go left, left, I go up here. That's 0, that's 0, that's one node. I come up here, 0, 0, that's two nodes. Every time I get back to the parent, I can add one to the node, and then I'll see how many, let's see. Oh, actually that wouldn't work, right? Because here, I guess it wouldn't really work well for, yeah, this wouldn't work well because in this case here, if I'm modifying sum globally, or not sum, but count, where count is the amount of nodes on each level. Let's see, because 5 only has, let's see, for the node with value 5, the average of a subtree is 5 plus 6 divided by 2 equals 11, divided by 2 equals 5. Yeah, so it's not that I necessarily need to reset anything. How can I keep like a distinct count per subtree? I want to think about how we can do this. There also might be something else that we can do though, because here, like what if I did a level order traversal? Because like 8 has 2 and then 5 only has 1, so that makes it maybe a little more difficult. 5 has however many nodes here and however many nodes here. 8 has however many nodes here, however many nodes there. But then what happens when I come here, right? Am I just always passing? Are we always just passing? So where am I stuck right now? I'm trying to figure out how to always have a distinct amount of nodes without bubbling the total amount of nodes. Because if I were to keep the amount of nodes global, that means when I get here, then I'll get to like, this has 0, this has 0. Okay, well, but then that's 1 for each. Here, this has 2. Here, this has 3, but then we get over here, and like I've already counted 3 nodes on this side, but I haven't only counted the nodes on the right side of 5. What if we also just had, let's see, 1, the number of nodes in the tree is in the range 1 through 1,000. Okay. I think the most important thing is figuring out how many nodes are in the subtree of this one. I could get the amount here. I could get the amount here. And I can bubble that up. What if I did something else where I'm like, would like pre-processing it work? Not pre-processing it, but there's the different types of traversals, like pre, post, and in order. If I did in order, which is 1, that still wouldn't help because I'll still be visiting this one last and I would have already counted all these. The thing I don't like about that is like, well, I guess if I call it for left here, okay, and then I call this for left, I could at every node. See, I don't love that though. Like, what if I had a function that just takes in a node and does that, where it can just take 5 and count however many nodes? But then that means like I might be doing double counting. So it's like I only want to take care of the right side. I only want to take care of this side and only this side. Count nodes equal to average of subtree. Return the number of nodes where the value of the node is equal to the average of the values in its subtree. Thinking about this. What if I have, oh no, it's not so much the sum, it's also the amount of nodes. That's the tricky part. How do we get the amount of nodes at any single, this has 1, this has 1. This also has 1. Oh, so maybe I just need to get the left and then the right here. Because I was almost thinking about doing something like, let's see. Let's say let node count is 0. Let sum equals 0. And then here we can do post order. Here we'll call this, I'll just call this R for root. And down here, I'll make sure to return post order root, not return, but let's see, let node count, let sum, then here let's say let average count equals 0. Here we'll return average count. This is sort of the template I want to go for, but my thing was like, we're gonna have at least one node, so we don't have to worry about a null root. Yeah, my thing is, so if I start this with post order, and if I just returned 1 plus that one, what if we did something like, let's see, const left node count equals post order r dot left, const right node count equals post order r dot right. Okay, here, what's the base case? I guess if r is equal to null, I can just return 0. And then here, what is it that I'd like to do? For this specific node, I could also return left node count plus right node count plus 1. Console.log r.val. I guess we can do left node count. Well, yeah, let's do left node count and right node count. I want to see what this prints out real quick. Just doing like a little bit of a test. So for 0, let's actually look at our painting, not our painting, our drawing. Or let's look at the drawing here. So for 0, we have 0 on the left, 0 on the right. For 1, we have 0 on the left, 0 on the right. For 8, we have 1 and 1. Okay, for 6, we have 0 on the right. Oh, so see, that does work. So why is it that I'm getting messed up then? Because 5 has 0 on the left, 1 on the right. So you would just take 1, 2, 3, 4, 5, 6. Well, you'd also need to add itself too, because this is just, yeah. It would need to be 3 plus 2 plus 1, which is what this plus 1 does down here. And that's what we can divide it by. So here we can say const node count equals this, right? Because that's the thing we actually want to divide by. Here I can say that if math.floor of root.val divided by node count is equal to root.val, and this shouldn't be root, it should be r, right? Then we can say what? We can say average count plus or equals 1, return node count. So would this work? Since we just kind of saw, that's 3 and 5. But wait, because so node count is left node count plus right node count plus 1. We saw that 4 did have 3 on the left, it had 2 on the right, but that's 6. So we need r.val. Oh wait, the thing that we're missing is the sum, right? We're missing the sum. We're definitely missing the sum. So maybe what I can also do for the sum, let's see, here we'll say, so const left node count, right node count, sum plus or equals root r.val. Then I can say if sum divided by node count is equal to r dot val at average count plus or equals 1. And just, yeah, let's actually see what sum is coming out to here. R dot val console.log r dot val and the sum. What is it actually here? So when it's 0, the sum is 0. When it's 1, it's 1. When it's 8 is 9. Okay, no, that's fine, because 8, okay. So when here, okay, see, that's where it gets a little trickier, because I don't want to do the sum every single time. What I need to do is I get my left node count and my right node count. Maybe what I can also do is something similar for sum. Like, what if I instead return, let's see, what if we return an object where we have sum is 0 and node count here? I have something like node count is 0. What if I were to do that? And then here I can do const left node count. Okay, okay. Let me now remove this. What do I want to do? What do I want to do here? Here we can do return node count and sum. Right, now what is it that I return here though? Post order r dot left will return a new object that has that sum. Maybe I should always pass in like 0 here. Maybe that's what's gonna be what helps me. What if sum was always a 0 here? 0 and 0. I can forget this here. Or no, we'll still do r dot sum node count and sum dot 0. Sum here will be, and let's say current sum. This will just be 0. Sum here equals current sum plus root dot val. Okay, so now what if in here we did r dot val left node count, and then we also did right node count. Let's see what this gives us. Is it gonna look a little better? So when it's 0, the node count is 0. Okay, when it's 8, the node count, it says 1 and sum of 4, so that's crazy. That's completely off. Because I would imagine that if I'm passing, if r equals to null, then we should just return a node count of 0 and a sum of 0. Left node count is post order r dot left of 0. Right node count post order r dot right of 0. Node count is left node count plus right node count plus 1. Here we'll just return the node count and sum. That's the current sum plus root dot val. The thing is, we're not actually getting, yeah, here we should be returning, we shouldn't be using this, right? We need to be using the result of left node and right node count. So that's where it's getting a little bit tricky. I'm gonna revert some of this code because I feel like I made it a little bit harder to understand. I think we were making pretty good progress when we were around, let's see, when we were around here, right? Because here we know that this is node count. So I feel like we're pretty close, right? Because 0, 1, 8, we have 3, including itself. 4, right? 4 will be 6. 5 will be. 5 should not be 2 though. Oh no, 5 should be 2 because it's including itself. So now we just need to get the sum at that node. If we have the left node count, see, this is where it gets tricky for me, because how can I return, or should I even return, multiple things like that? Node count, average count, haven't done anything there, and then sum. I feel like it has to do something with sum. Because I could pass R and then sum equals 0. For each one of these, I pass sum and sum. Console.log, r.val, and node count. Let's see. What would be the best way to pass both back? Unless we also just... No, that wouldn't work. Left node count, right node count. I think we have to use an object here because I want to keep track of multiple variables throughout this. It's not just the node count or the sum. Left node count. Tricky stuff indeed. Left node count and right node count. Maybe instead of... Maybe I was onto something by doing this though, because we could say this is node count is 0 and sum is 0. Left node count, right node count. Node count is left node count. Return, but see, what do we return though? Like when I get to here, okay, and then I get there, what do I return here? Do I modify? Do I return a new object where I have like node count? No, that's going to be tricky. Is there another better way of getting the node count instead? Ah, we're so close. I know we're so close. That's the thing I'm so annoyed about. I know I'm so close. Give me 1 second. Let me go ahead and turn my phone off so we are not hearing all the different notifications there. Post order R sum equals 0. I can't calculate the sum of the whole tree because by the time I get here, I'm going to have calculated the sum of all this side, right? I need to only worry about the sum of this tree. R.left, and we're just returning 1. Man. It's like frustrating when you know you're so close and you're just missing that one thing. And I keep going back to, you know, do I need to? Would it be easier if I just had... Okay, let's go back to the drawing board, right? I have all the pieces here. I need to be able to just go down this tree, and then for one of these, I can get the sum. I can probably get the sum in the same way I'm doing the node count, right? Because we've noticed that like each one of these node counts are specific to its subtree. So if I did the same thing with sum, that still wouldn't really solve the problem of the node count. However, I do want to see, yeah, let's try this the other way. Like what if I did instead, let's copy this and then comment that out. So we're going to create the same function. It's going to go back to using R, but this time I'm still going to return 0. Here I'll say left sum post order r.left. Here I'll say right sum post order r.right. Nodes count total sum is equal to left sum plus right sum plus root.val, right? So here, let's do console.log r.val and total sum. And here we can just return total sum. But I want to see what this comes out to. let's get our picture again. So when it's 0, so see here, this is already weird. Because this is doing post order r.left, r.left. It goes over here. Then it does right, and then somehow we get left sum plus right sum plus root.val. This should be 0. This should be 0, 0. Like I don't know where the 4 is coming from. Total sum hasn't been modified yet. So when we get to 8, somehow that's 12. Const left sum equals post order r.left. If r equals null, return 0. So this is going to call r.left. Const left sum is post order r.left. Okay, const left sum is post order r.left. Here it's null, so we return 0. So left sum is 0. Right sum is post order r.right, we return 0. So it's 0 plus 0 plus, oh, root.val. This should be r.val. Okay, so here we get 9 because we're adding that one. So 5 is what? 5 plus 6. Okay, so this is 9. That's fine. So now we have the total sum. Now, can I modify this to give us an object now? Like if it's null, I can just return sum of 0. Else, maybe here we should return an object that's equal to total sum. But see, now what do we do for, let's see, if left sum, if I go post order r.left, post order r.left, okay, I come here, so I have left sum dot sum equals 0. Over here I have right sum dot sum equals 0. So total sum should be equal to left sum dot sum plus right sum dot sum plus r dot val. And then here we just return r dot val and total sum. So what does this come out to? The same exact thing. Okay, well, it's gonna be the same thing. Total sum is still the same. Now, can we get the node count from there? Now, if I did node count 0, how can we change this? Can we just do node count is left sum, or I guess we can do left sum, right sum. We get total sum. We can say total node count equals left sum dot node count plus right sum dot node count plus 1. And then over here we can just say return node count, total node count, and sum total sum. So now I want to log total node count along with total sum. Let's see if that helps. So 8, 3, 9. Okay, there you go. I think we're looking good now. 5 plus 6 is 11. Oh, there you go. I think that's it. So then here, all I need to do is the same thing. Now we can say if math.floor of total sum divided by total node count is equal to r.val, we can say average count plus or equals 1, and then we'll return average count. So is this gonna work? 5 and 5, okay. 5 and 1, 5 and 1. Let me go ahead and remove this, and let's submit it. Oh, that's so awesome. Yes. Wow, what a great exercise in like perseverance. I'd be lying if I didn't say I was like about ready to give up in there for a little bit. And I think half an hour for like a medium question, probably a little less, because as you know, if you've been watching me for a little bit, you know that typically in the beginning of my streams I talk a lot. I'm generally just like a very talkative person. So yeah, that's awesome. Let's look at this. Like average count I do need. Node count I'm only using in the context of an object, so I don't even need this one. And sum is the same, right? I'm using sum in the context of an object, so I don't need that one. Yes, the tree questions are definitely annoying, but whoo, man, that was like an adrenaline rush. Like I said, I thought I was gonna like give up, man. I kept going, and we figured it out. So it's always been a little bit confusing for me. Like here, we needed to keep track of multiple variables, I think. I mean, I'm sure there's a very elegant way of returning something that some other way, or doing it all within the same function. I'm sure if I look at the solutions, there's going to be like a 2-line answer. But I'm just happy that the main takeaway for the people that are watching is, let's just forget about how everyone else is doing. Let's just focus on this stream right now and the people that are watching. The biggest takeaway of this stream is the fact that we stuck with it and we got it. Like, that's the most important thing. I think if you're just putting yourself through that and coming out victorious, that's the most important thing. And I'm pretty happy with the way we solved it, because we're traversing the entire tree once. So let's say a time complexity of O of n, right? And then as far as our space complexity goes, like, we're not, like, all these operations are constant. So really we're just bound by whatever internal stack space is taken up by this algorithm. So assuming we have a height balanced tree, that's going to be O of h, where the stack will never grow to be taller than the maximum height of a tree. If this tree was skewed in any one direction, left or right, and it sort of started trending towards a linked list, then it would be O of n, since we'd have to accommodate all the nodes in our internal stack. So I'm happy with a linear time complex algorithm and an O of h space complex algorithm, where h is the height of the tree if it's a well-balanced tree. MJ asks, how many LeetCode questions do you do a day? So I only do LeetCode during these streams. This is the only time throughout the day that I do LeetCode. And I feel like if we're doing easy questions, so easy questions I do Monday, Wednesday, Friday, and I suppose I'm going to start doing medium questions on Tuesday, Thursday, and Saturday. I'd say on a really good day for a easy, like 3 to 5 questions, but it has to be like a really, really good day. Probably more often than not, we do 2 or 3 for easy questions, and for medium, probably the same. I like to keep my streams to about an hour in length, not because I can't go longer, but because, like, let's just go back to my YouTube channel real quick and let's look at how I started this whole thing. So my first ever playlist is called LeetCode Live Easy Collection. I used to call this LeetCode Accountability Stream number 1, because for me, I wanted to make this, like, think about when you're binge watching like Netflix or something. You can plan your binge because you know how long each episode is going to be. So you can say, okay, I'm going to binge for like the next 3 hours, and I can plan for that. So I think to be accountable and consistent, it's good to also have a consistent resource. So by me keeping these streams to mostly an hour, some of them, sometimes they go to an hour and 16 like this one, or they're shorter, 32 minutes. But it means that pretty much on any given day, you only have to do it for an hour. You only have to watch the stream for 1 hour. So I think that's like a very easy and reasonable goal. You tell yourself, I'm going to do the questions first and then watch the stream, or watch the stream as I'm doing the questions. That's going to be my daily LeetCode habit, and I'm going to do that for an hour a day. Because if you do too much, you're going to burn out. And if you do too little, you might feel like you're not doing enough. So that's why I normally keep them to an hour. And if you're new here, by the way, all the streams that I have, like all existing streams, and I've updated a lot of them because a lot of them I wasn't actually able to like include these, but I have chapters on all these and links to all the questions that we do. So you can just like hit any one of these. You can quickly go to any of these chapters and then see the question you want to solve. And then on top of that, for even newer people on the stream, I have my website, raphaelslist.com, which you can think of as sort of like a Bible, a compendium of sorts for my YouTube channel, where I have a list of all the top quality easy questions I've come across, and also a list of all the top medium questions I've come across. Each one has a link to the stream where I solve that question. And it puts you right in the chapter where we do it. So I think that's pretty beneficial, and I hope it's beneficial for all you people watching. So MJ adds, I stopped doing easy. I went for an interview with Microsoft and I wasn't given any easy questions. Yeah, no, I totally understand as well. I've also done Microsoft interviews, and this stream that I'm doing is not so much me teaching you how to LeetCode. It's mainly, I mean, really, if I'm being honest, it's almost like a form of entertainment. But I set a challenge for myself to do every single LeetCode question. And I thought, why not just stream myself going through it and see if I can meet people and reach out in the community and get to know all you. And it's been extremely gratifying and satisfying to do that. So if you're watching the stream, then I wouldn't think to yourself like, oh, he's only doing easy questions and it might not benefit me too much. This is mostly like if you've never done easy questions or if you've never done LeetCode, you can watch these streams. Maybe if you just want to take a break, you want to relax, you can watch the stream. You can maybe hear a different perspective. You can watch someone do it in a different language. A lot of these LeetCoding resources are not done in JavaScript. But to your point, I also, I realized there was also value in doing questions that were a little more like tailored. So like even, if you go on my YouTube channel, you'll see that I've even started branching out to, like, one thing I thought would be cool to do was playlists for the different Explore cards. So like I have a playlist for the LeetCode Beginner's Guide, a playlist for Arrays 101. So on top of the long form streaming, I also want to be able to not only provide a wide variety of content, but also provide more tailored experiences for those that are maybe more in that grinding phase. At the end of the day, I'm just looking to be another resource that you all can add to your tools, your toolbox, because I realize that LeetCode can be extremely frustrating, and I think it's just good to get a lot of different perspectives from a lot of different places. All right, cool. I'm very happy with that question. Thanks a lot for the great questions you all have been asking. Let's see if we can get to the next one. So group the people given the group size. I think I've done this one before. And this one's nice because it lends itself well to a pattern that we'll see later on. So let's go ahead and read the question and let's see. So far, I think like this question, definitely adding it to my list. It's really nice. All right, so there are n people that are split into some unknown number of groups. Each person is labeled with a unique ID from 0 to n-1. You're given an integer array group sizes where group sizes of I is the size of the group that person I is in. For example, if group sizes of 1 is 3, then person 1 must be in a group of size 3. Return a list of groups such that each person I is in a group sizes I. Each person should appear in exactly one group, and every person must be in a group. If there are multiple answers, return any of them. It is guaranteed that there will be at least one valid solution for the given input. So this right here is a nice keyword, and it makes the question easier. We don't have to return the answer in any specific order. So this means that we can just sort of add our results to some output array and just return it however we feel like it. One thing that I don't remember looking at before is the constraints. That's something that I've been trying to focus more on during my streams. So let's see what the constraints are, because they often can give us hints as how we can better optimize our solution. So it says that group sizes.length is equal to n, 1 is less than or equal to n, 500, and 1 is less than or equal to group sizes of I less than or equal to n. So because this is a pretty small size, I'm going to go ahead and try to do this question with a fixed size array. But before I even do that, let me show you all sort of like what I'm thinking about doing. So group sizes 3, 3, 3, 3, 1, and 3. The first group is 5. The size is 1, and group sizes of 5 is 1. So, oh yeah, because it says group sizes of I is 3. That person 1 must be in a group of size 3. So it means that people in 0, 1, and 2 are people 0, 1, and 2 are in a group size of 3, and then 3 and 4 is in 3, and then 5 is in 1, and then 6 is in another one of 3. So if you think about that, like, what if we had an array that was, well, of size, let's make it length 4, right? And just hear me out. Like, I hope you all can see the screen. Let me zoom in like one more to make it maybe easier. So over here we'll have, I'm just going to fill this up with empty slots for now. Okay. So we have here that like groups 0 or people 0, 1, and 2 belong in a group size of 3. So what if at position 3, what if this was essentially our groups, right? Where every index represented a group. So like index 0 represented group 0, 1 represented group 1, 2, 3, so on and so forth. So 3, 3, 3, which means that we'll put like in index 3, which is 0, or which is here. Imagine we had an array that was, okay, person 0, person 1, and person 2, right? What we can do is as soon as we hit the size, then this can become part of our output. What do I mean by that? Like, I'm going to add person 0, I'm going to add person 1, I'm going to add person 2. As soon as I try to add person 3, I'm going to see that this group's already of length 3. So it means I need to first add this to my output, reset the array, and then add the new person, right? And I can continue doing that all the way until I finally get my output. Now, the reason I want to do it this way is before what I used to do is I used to create an object literal. I would essentially do the same thing where I'd have groups like this, right? And I'd have something similar where like, okay, group size of 3 would have 0, 1, and 2. Group size of 1 would have 5, so on and so forth. But the reason that this is not as optimal is because the JavaScript engine, or the engine wherever your language is executing on, it's going to have a harder time optimizing this because it can't know ahead of time how big this possibly can become. It might be a micro performance gain, but if you do something like create a fixed size array, we're specifically reserving a fixed memory block ahead of time. So it's easier for the engine to optimize for this sort of thing. So that's sort of what I want to try out. What I'm going to do is I'm going to say const groups is going to be equal to a new array. So group sizes dot length is n, and we know that n is going to be less than or equal to 500. So I'm going to say group sizes dot length, and I'm going to add 1 because it's less than or equal to. So I want to be able to actually index the 500th indice or index instead of 499. So I'm going to add 1 to that. What I'm going to do now is, let's see what we can do. Let's get our const groups. Let's also get our groups output equal to an empty array. Then we can say, let's see, for let I equals 0, I less than group sizes dot length I plus plus. We're going to take the first group size. So const group size equals group sizes of I, right? First thing we need to do is we need to look inside of our index. Imagine, let's go back to where we had this, right? First one is 3. If we go in there, and actually right now, let's see. What we should do is actually we should fill this up with 0, and I'm going to tell you why. If I don't fill this up, this is going to be what's known as a sparse array, where sometimes this can be an undefined value and other times it's just an empty slot. But it's not the same. A sparse array is not the same as filling in values with the undefined value like this. But I'm going to fill it up with 0. And what we can say is the first time I try to index 3, if it's a 0, I know there's no array there, right? So if, let's see, if groups at group size is equal to 0, what I want to do is at the same location, let me delete this extra G. I want to say groups at group size is now equal to an empty array. So I've identified there's nothing here. So I'm going to set it to be an empty array. Okay. And then at that location, I'm going to say groups of group size. Here, we're going to push I. Now, before I do that, and I'll show you what's going to happen. Well, actually, let's go through what we have right now, and then let's figure it out. So I'm creating this with all zeros. So we're going to have a 0, a 0, a 0, a 0, a 0. Let's get this array here, and let's see so far how this is going to run. So this is where I is in the beginning. So I say const group size is group sizes of I. So group size here is 3. If groups at 3 equals 0, so 0, 1, 2, 3, it is 0. We're going to set groups at index 3 to be an empty array. Then we can say groups at group size, which remember is 3. So groups at this index, this empty array, we're going to push I. We're going to push 0. Now we'll get to the next one. Same thing, right? We're going to go to 3. It's not 0 anymore. Now it's this empty, or rather this array. So we're just going to go ahead and push 1. We're going to get to the next one. We're going to push 2. Okay, now, when we get to the next one, 3. Okay, it's not 0, but if, let's see, if groups at group size dot length is equal to group size, what do we need to do? Well, we need to actually output the thing that we have in there. Groups.output.push groups at group size. Okay, so it's like we're taking this array here and now we're pushing it to this output like this. And we also need to make sure to reset it, right? So here now we'll say groups at group size is equal to an empty array. So that way this becomes an empty array. And now we're still here where I is what, 0, 1, 2, 3. So now we'll just put 3 here, exactly how it shows up in here. So I've never tried it this way, but I'm very curious and I'm hoping that it works. I feel like it can, but of course we will figure it out. If this, I have a feeling there might be an issue here just because of other questions, how I've tried to just push an array reference. I might have to spread it, but let's see what we get. So let's do return groups. Actually, no, return groups output, right? Return groups output. Okay, so 0, 1, 2. So it's like we got the first one right, but then it didn't do anything else with any of the other stuff. So that's very interesting. I'm very curious as to why that happened. So let us see what happened. Groups at group size dot push I. Groups at group size is equal to empty. And if we get to so 3, 3, 3, we get to this one. We add 6. Oh, you know why? I think what needs to happen, I think maybe this needs to come, let me think about this. Yeah, I think this needs to come after we push. That way, as soon as I add a 2, because what happens here is when I add the 1, right? Let's actually backtrack and look at this real quick. When I add the 1, it's going to be 0, so I make it an empty array. It's not equal to group size yet, so then I go ahead and add the 1. But we never got a chance to actually see the 1 and do the check to see if it's the size. So I think because of that, we should put this on the bottom there. So here we get 0, 1, 2, 5, and 3, 4, 6. Very nice. Let's do it for our next one and see. So we got 1, 0, 5, and 2, 3, 4. Okay. Remember, it can be in any order because they've told us that we can return any of them if there are multiple answers. So you have a 0, 1, 2. We have a 0, 1, 2. We have a 5, 3, 4, 6, 3, 4, 6. 1, 1, 2, 3, 4, and 0, 5. Cool. So let's go ahead and submit this. Yeah, 23.05. So I'm very happy with this because normally, like I said, I try to do this with an object literal. But I liked that constraints are very important here, right? Reading the constraints, this is a habit that I really had to build up on. I had to work on it because it's not easy to just like, well, it's like any habit, right? You have to practice it. And I didn't realize how useful the constraints could be until I started really paying attention to them. Again, because this was such a small size, I felt like, well, we can just optimize and just create a fixed size group array and then operate on that. So let's go over this again. So we have fixed size group array. We have groups output. That's just going to be the output. What we do is we start building up these arrays individually. So we start adding 1 to 3, or we add, let's see, person 2 to group 3, person 3 to group 3, person 4 to group 3. As soon as we see that group 3 has reached its limit, we can add that to the output and then reset the size so that the next person in group 3 can be added to a new group. And let's think about the time and space complexity. So here, I mean, really, we're just going through group sizes.length. There isn't anything else. Like everything else these are all constant time operations that we're doing here. So this is just O of n, linear, where group, n is equal to group sizes.length. And as far as our space complexity goes, I wouldn't say that it's constant, because how much we're going to use at least the length of group sizes.length plus, oh, I guess at the end it becomes, actually, I guess it becomes constant because you'll still never have more than whatever we're given, right? We're not going to be, and it's not determined by the size of the input. So I feel like maybe linear time algorithm with a constant space complexity is the way to go here. And I feel pretty good about that. I'm very happy with this answer. So hopefully you all learned a little bit from this, and I'm absolutely going to love this answer. or rather love this question because I think it is really nice. So 2 solid medium questions today. You know, yesterday I feel like the stream didn't go that well. Just the questions were just bad. So it's always really nice to see high quality questions like the 2 that we've just done. Okay, minimum amount of time to collect garbage. We tried that one a while ago, so or maybe like 2 days ago. So let's try sum of nodes with even valued grandparents. So given the root of a binary tree, return the sum of the values of nodes with an even valued grandparent. If there are no nodes with an even valued grandparent, return 0. I think I've done this one before, but I think the way I did it was I did a post-order traversal where pretty much at every node, I just check 2 things. I say if I have a left node and that left node also has a left node, and right, because it needs to have with an even valued grandparent 2. So why would it be, okay, we have 6 in here, but then why do we have 2? Grandparent of a node is the parent of its parent if it exists. The red nodes are the nodes with even value. Okay, wait, the red nodes? I'm colorblind, but I definitely don't see any red here. The red nodes are the nodes with even value grandparent, while the blue nodes are the even value grandparents. Okay. Given the root of a binary tree, return the sum of values of nodes with an even valued grandparent. Oh, so we did 2 plus 7 is 9, 10. Okay, I see. So for this one, for example, we just see, okay, if it has a left and this one also has a left, then we just add that value. If this one has a left and it also has a right, then we just add that value. And we keep doing that all the way. So I think what we can do here is, let's first, what's our base case here? You know, if not root, we can return 0. I think what we can do now is we can say const left sum equals root dot left, const right sum equals root dot right. Okay, and now we can say const new sum equals, let's say let new sum equals 0. Let new sum equals 0. Now here we say if, I wonder if we can use optional chaining here. What environment does, wait, LeetCode environment. Does this use Node? Or what version of Node does it use? Okay, wait, so can we use optional chaining? Because if I do if root dot left, if root dot left dot left, then use sum plus or equals root dot left dot left dot val. And what happened here? If root dot left dot left new sum plus or equals root dot left dot left dot val. Anytime I see one of these indentations like this, does it not like the optional chaining? It might not. It might not. If root dot right or dot left dot right new sum plus or equals root dot left dot right dot val. If root dot right dot left new sum plus or equals root dot right dot left dot val. If root dot right dot right new sum plus or equals root dot right dot val. Root dot right dot left dot val. Return new sum plus or equals, or we can just do return left sum plus right sum plus new sum. Let's see if it likes the optional chaining. It might not. I really hope it does. 32 and 18. Okay, that's okay, because that just means that I guess it does. It's cool with the optional chaining. It just doesn't like the answer we came up with. Oh, and wait a second. it has to be even valued grandparent. So if root.val modulo 2 equals 0, then we can throw all this in there. Let's run this. So we got 18 and 18. Let's do the next one. Oh, one should be 0, no? Okay. 18 and 0, okay. Let's do the next one. Not the next one, but let's submit. Okay, 32.77. So very similar. A lot of these tree questions have very similar complexities. So again, this is linear because I'm still going through every single node in the tree. And for every single stack frame, it's constant time operations we're doing here. And then the space complexity, if it's a well-balanced tree like what we have here, no two heights ever differ by more than 1. So the height, the internal stack space that the traversal will take won't be more than O of h, where h is the height of the tree. Now, this has been one of the best streams I think we've done here. We did three solid medium questions, very high quality medium questions. And, we talked about them, we discussed them, we sort of like learned the ins and outs of them. I hope that this has proven insightful for those of you watching. I think this question is very cool. One thing I do like a lot is, we were able to see, like, there's this really nice website that I probably already closed already. The one that I was just on with LeetCode environment. It tells you the environment that LeetCode is using for any one of your different languages. So I wanted to see what version of Node LeetCode uses for JavaScript, because I believe as of Node major version 14, it uses something called optional chaining. So if we didn't have optional chaining, then we'd have to do something like if root.left and root.left.left, right? Which is not very nice. Here you can just sort of condense that, and instead of this throwing an error or anything, it would just return undefined if any of these is null, right? And we know that if undefined is falsy, so it wouldn't never enter in any of these conditions anyway. So very cool stuff. I really enjoyed this question. And again, I'm hoping that everyone else watching also enjoyed the question. By the way, I'm sorry if you all hear any background noise. Hopefully there's not too many. I think there's someone like mowing their lawn. That's just like typical Florida stuff, like hurricanes coming. Let's mow our lawn. Why not? And yeah, I think with that, I'm gonna probably wrap it up here. For people that are new to the stream, a quick recap of some stuff that's gonna be happening in the near future. So I'm gonna be going on vacation in about 2 weeks. What I'm gonna be doing is I have questions like after this stream. What I'm gonna do is I'm gonna do a local recording of myself doing the same thing that I'm doing here, except it won't be live by the time you watch it. However, I'm gonna schedule it to come out at some point during my vacation. So when I'm out, you'll still be getting videos. It won't be live, but at least there'll be no shortage of content for you to watch and learn from. So with that being said, I hope you all enjoyed the stream. If you like this sort of thing, follow me on Twitch, subscribe to me on YouTube. I really, really hope to see you around on those platforms. I've been having a lot of fun with this, and I'm just looking forward to growing more with you all and getting better myself and hearing about everyone's progress and where their LeetCode journey has taken them. So with that being said, hope you all have a great rest of your Tuesday.